Welcome everybody to Greywater Action's 2015 webinar series. I'm Laura Allen with Greywater Action, and I'm here today with Nicholas Holmes, who's going to be talking about branch drain systems and greywater in arid climate. Before we get started, just a couple of housekeeping notes. There is a chat box on the left, so you can type in questions, comments, anything you're wondering about anytime throughout the presentation, and we'll be pausing a couple of times throughout the presentation to answer your questions. And we will also have time at the end for questions. If you want to see a larger version of the presentation, you could click in the upper right corner of the slide and you'll enter the full screen mode. So without further ado, we'll get started. Thank you so much, Nicholas, for joining us today.
Thanks, Laura, and hello, everybody. Just start with a little introduction, a little bit about myself. I actually got into greywater systems through architecture and have a degree in architecture and sustainable design and development from Cal Poly San Luis Obispo. And I moved to Joshua Tree, back up here, Joshua Tree in 2006, and you can see a little place in the middle of that photo. It's where my family and I live. And a couple of years later, in 2008, I got started with my first design and construction jobs for greywater systems. And so when we're talking about arid climates, this is what I'm referring to as an arid climate. We get less than 5 inches of rainfall a year out there. And as you can see in the photo, it's a pretty sparse landscape. And by definition, arid is just any landscape where the evapotranspiration rate is higher than the rainfall that they're receiving. So a lot of Southern California is considered arid landscape. And so some of the stuff we'll be talking about there would apply in any arid region really around the world. So moving on here into the presentation, a quick outline of what we're going to be talking about. First going to have an overview, introduction about branch drain systems and talking about the planning and design considerations involved. And then we'll go into the specific elements of the branch drain system and as well as installation details and kind of a step-by-step going through installing a system. And then towards the end there we'll talk about maintenance and a few additional options and the resources. So a branch drain system is a gravity system, and this system was first invented by Art Ludwig of Oasis Design. And for this system, it depends on having a landscape that is lower than the greywater sources. And that's because the system is a gravity system where the pipes distribution piping is set up at 1/4 inch per foot slope and brings all of the water to the sources via gravity. You also, to use a system like this, you have to have access to all the drain plumbing. And a branch drain system does require a permit because you're cutting into existing drain piping in the house. And costs of the system can run anywhere from $800 to $4,000 for professional installation and just the parts alone. I've installed some systems that are even slightly less than $150 in terms of parts. And if there's going to be multiple diverter valves and actuators and switches, could be climbing up there more like $500. So it's pretty big range of costs, and a lot has to do with what's going on outside in the irrigation distribution. Is everything happening close to the structure, or is there going to be long runs of trenching across the landscape? So it all depends on a lot of factors outside as well. Looking at an overview diagram of some of the other elements in the branch drain system, there's a couple of close-up images here. You can see where the piping is coming through the structure and before going to the outside. And there's a good image there in the upper left where it shows a sanitary tee combo fitting with a clean out on it. And that's added there so that the system can be flushed out by opening up and putting a garden hose down, or a snake if need be, if there's some sort of a clog in the line, which is an extremely rare thing. And then you can see the various elements that distribute the water to the mulch basins, the flow splitters that are set in irrigation boxes that are accessible, and the water then ending up in outlets that are in mulch basins. And what's missing in this diagram, the last part of the greywater system, is the plants. It's not a system unless there's plants that are actually using this gray water. Otherwise, it's just gray water disposal. And for those plants, what's most appropriate to use to irrigate is trees, bushes, vines, larger annuals and perennials, any of the larger plants really. And so in this next image, you can see how the flow splitters will affect the amount of water that ends up at an outlet. And so a flow splitter, when it's set level, will split the flow of water in half. And so if you have a known amount of gray water from a source inside, you can figure out by how many flow splitters you want to use, how much water that's going to end up at the outlet, and then you can match that in your design with the plant needs. And if certain plants need more water, you just have fewer splits before it or several outlets that could be around it. And so you have different options there. And this isn't necessarily to scale. One of the things we'll be talking about later is we try to have at least 2 feet of straight pipe ahead of any flow splitter if the goal is to have even flow splitting. In some cases, it's difficult to do that because of site constraints, but best practice is to try and have 2 feet of straight pipe before each splitter. And these are some images that you've already seen if you've been taking part in earlier presentations in this series. Oops, go back one, of a system up in San Francisco. And you can see the distribution piping and some mulch basins that have been dug right there at the outlets, and valve boxes that are being used as mulch shields in the outlets. And there's a mulch basin with a mulch shield in the outlet. And that same system 1 year later, at completion, and on the right 1 year later. And apparently this landscape, once the system was installed, the homeowners never had to irrigate this landscape again. The gray water was able to take care of all their needs. Granted, this is not an arid climate, this is in San Francisco, but that's pretty exciting nonetheless that there was no irrigation needed. So talking about some of the considerations that you have to keep in mind when you're starting the process of design and planning for a gray water system. That includes what sources of gray waters you can access and how much gray water those sources are going to be able to produce for you, as well as what the depth is that the pipe's starting out at outside the building, if it's an existing pipe, or if you're able to bring that, to access that pipe in a crawl space, for example, how deep you're able to exit the building. In some cases, you can bring the pipe above grade and then where you have the clean out there and then go underground. And we like to start as shallow as possible for installing the irrigation distribution plumbing outside, and I'll get into why a little bit later. And then you have to consider that these pipes must maintain a minimum of a 1/4 inch per foot slope in the system. And this is really important, especially if you have a flat site or you have some plants that are a little further away and you want to get all the plumbing all the way over there. You have to have ways to make sure that you're maintaining that 1/4 inch per foot slope and not more or less. And it's preferable also to have the 2 feet of straight pipe, like I mentioned before, ahead of the flow splitters, and sometimes it's not always possible. And then considering what plants in your landscape that you're going to irrigate, and remembering to match the plant water needs and zoning those plants in that area so that you're not placing plants that have really high water needs right next to plants that have low water needs. And then if there's any obstacles to go around under, over, such as concrete slabs, existing trees that aren't going to be irrigated, any other pipes or things that you might encounter, and all that you just need to keep in mind. Sometimes you don't know that some of these things are there and they're unforeseen conditions, and you just have to adjust and modify during the installation. So looking at the gray water sources, this is really true for any type of gray water system, but talking about which gray water sources are most appropriate for branch drain systems. There's the showers and baths, washing machines, sinks, including the bathroom sinks, laundry, and garden sinks. And by garden sinks, I'm talking about, it could be a sink outside in a potting shed, or maybe one in an outdoor food prep area, something like that. And then lastly, there's kitchen sinks, which in California anyhow, this is not yet legal. is what we refer to as pre-legal. It's implying that someday this law will hopefully change as kitchen sink water is as really great water for greywater systems, especially with the branch drain system. And then some other possible greywater sources that are not necessarily good for having their own branch drain system, but could be good for adding on, tying into another branch drain system that's already there, or one that you're putting in. And that would be air conditioning condensate drains or evaporative cooler bleeder lines, purge lines, as well as reverse osmosis water filters and whole house water filters. And by whole house water filters, I'm not referring to water softeners, but more where you have the types of systems where you have a filter tank that's full of activated carbon filter media, such as the coconut husk, that type of thing. And these are fairly large tanks. They're maybe 8 inches to 12 inches in diameter and several feet tall, 4 or 5 feet tall even. And these tanks have an automatic backflush system where once every week they take potable water and flush the system to reorganize the filter media, and then that water drains out. And that's definitely a useful source to be able to capture that and tie that into a branch drain system. So of those sources, showers and baths, first off, this is my personal favorite because mainly it's some of the cleanest gray water. That's the lowest concentrations of soaps and things like that. There's so much water that's going down compared to the amount of soap that it makes it for a really great source. And it also provides a nice steady flow of gray water, and it's really a relatively large amount. Definitely a good choice for branch drain systems. And then next would be washing machines. And so even though we have the laundry to landscape system, which is very good to use, you can also do a branch drain system if you needed to have a system that, for example, if you had vermin that kept digging up and chewing into the high-density polyethylene tubing in a L2L system. With the branch drain system, we have this more robust piping that critters wouldn't necessarily be interested in chewing into, so it would be appropriate there. And really like this image here, I believe this is from one of Brad Lancaster's installations, it looks like it, and you can see various standpipes for different trees or zones. And so you have a zone system where each standpipe goes to a different source or different location in the yard. And it's kind of nice being able to have those options like that. And then we also have the sinks, of course. And like I mentioned before, all those sink sources, the bathroom, laundry, garden, and the kitchen sink outside of California. And there are other states that have legalized kitchen sink gray water use in the country, and others that have made it illegal. And so you just have to check with your state if you're not in California to find out if you can legally use kitchen sink gray water or not. And I won't talk too much about the diverter valves because Christina did such a good job in her presentation. And so if you want more detailed information, definitely refer to Christina's presentation about the diverter valves. But basically just to say that we do need to have the diverter valve in the system to be able to direct where the gray water is going, whether it's going to the landscape or to a sewer or septic system. And this is a requirement by code in California to be able to have that diverter valve. So the next element in the system is all the distribution piping and fittings. And these are all the blue elements that are in this diagram outside the building line. And the distribution piping itself, what we're talking about here is the black ABS pipe. And this is pipe that's typically used for drain, waste, and vent plumbing. And in our case, we're just using the 2-inch and the 1.5-inch diameter. 2 inches if you're starting out, if your plumbing source is already starting at 2 inches, such as a shower, any other sources at 2-inch. And then we usually reduce down to 1.5 inches at the first flow splitter because the 1.5-inch pipe is cheaper, substantially cheaper, and the fittings as well are cheaper. Once you've done that first split, everything else can be 1.5 inches, or in some cases, you're starting off at 1.5 inches, and so there's no need for the 2-inch. And then for all this distribution piping, you need to maintain that 1/4 inch per foot slope, as I'd mentioned, and I'll talk about a little later various ways to do that. the need for 2 feet of straight pipe if the goal is to have even splitting of water. In some cases, I've intentionally set the flow splitters at an angle because I didn't want even flow splitting of water, where I wanted, for example, 2/3 of the water to go one way and 1/3 of the water to go the other, and then I split that other 2/3 another time, so irrigating 3 trees with an even amount of water. And that's something that's a little more difficult to do, and it's just kind of trial and error just to get that angle right and testing, and we can talk a little bit more about that when I get to the testing area. And then with this pipe, there's so many different tools, easy to cut, reciprocating saw, tubing cutters. My personal favorite is the miter saw, makes for nice square clean cuts and really quickly, and then a hand saw. And oftentimes the ABS pipe, either right off the shelf or especially if you set it out in the sun on a job site, that it'll start to warp on you. And you need to keep in mind when you're working with that warp pipe to always put the warps or the sways side to side, never up and down. And that's to avoid creating any pockets or dips where you have any standing water within the pipe. And then with all those fittings, if you're making any 90-degree horizontal bends, we always want to use the long sweep fittings. And Christina also talked a lot about those difference between the long sweep and short sweep fittings. And so if you need more visuals on that, the difference between the fittings, check out her presentation. So the flow splitter, this is really the key element in the branch drain system. And they're typically sold in the 1.5 and 2-inch sizes. And you can find them at various specialty stores. Clean Water Components stocks them with the plug. I also have a little eco building supply myself out in Joshua Tree called Solstice Eco Building Supply, and I keep the 1.5 and the 2-inch flow splitters in stock as well. And then you can find other sources online without the plugs, sold as double L's, and plumbing distributors. And the flow splitters, as you see here, these are a modified version where we drill a hole in and tap that hole and put a 1-inch PVC plug, and that gives us the ability to have an easy to remove access plug as a clean out right at the source where occasionally particles might get stuck right on the spine in the flow splitter. And you can see a closer up image of that here. So that spine right down the middle, set flat, everything will just split nice and evenly, assuming you have about 2 feet of straight pipe ahead of it. Not all building departments will allow having a clean out in this way on the flow splitter because it's a dissimilar material. You have a PVC plug going into an ABS fitting. And so, for example, City of Los Angeles, they don't allow that. And so here's an image of an installation that Lee Gerard of Greywater Corps did, and where what they required was to do a clean out, so a Y fitting right up in front of the flow splitters at each flow splitter. So it's a little more work and fittings to do this way, but if the building department in your area requires this, you may have to do that, so keep that in mind. As another aside, they were also required to label the piping underground as Greywater, subsurface irrigation, non-potable, that sort of thing, which is a bit of an extreme requirement in my opinion. I don't know anybody who would ever see a black pipe that's typically used for sewer water to think that it could be confused for potable water, but that's what that city requires. So with the installation details for the flow splitter, like I mentioned before, if they're installed level and you have 2 feet of pipe ahead, you will get nice even splitting of that flow. And when you're installing them, it's important to set the flow splitters on a brick or a paver, a flat stone, something that will give you a nice stable pad, and to place that brick on well-compacted soil so it's not going to settle after everything's installed. Because we really don't want these things to shift and move around once we're backfilling. Once you've gotten all the flow dialed in as you want it, you want things to stay stable and stay put. And then important to install a valve box or a bucket. In the case of the image in the lower right, that's just a 3.5-gallon bucket with a hole cut out in the bottom and turned upside down. And then that way we have a permanent access to be able to get in and inspect the flow splitters and open up and clean it out if need be. And go back one more image. The image in the upper right, this was a 2-inch pipe that was coming out from a shower, and then it's stepping down to 1.5 inches. And so the reducing from 2-inch to 1.5 inches, there's several ways to go about doing it, and I'll just show you a few of those ways. This particular approach is one that I first learned in Art Ludwig's Create an Oasis with Greywater, where you're using a series of fittings to create slope, as you can see in this photo, right before the reduction to 1.5 inches, and that's to avoid having any pockets of standing water and crud that might potentially build up where the pipe size is reducing. And I'm not going to spend too much time on that. Then another way that some people do is to use these bell fittings or reducing couplings. And me personally, this is not what I would recommend, because what it does is it creates a little pocket of standing water within the flow splitter itself, because by nature the 1.5 inches, the bottom of the 1.5 inch pipe is going to be slightly higher than the bottom of the 2-inch pipe in front of it. And so the best solution that I recommend is, and I just learned about these recently and I'm super excited, is to use the reducing double L's. This is where you have a 2-inch inlet and 1.5 inch outlets on both sides, and that's your easiest, simplest way to do it. The difficulty is in finding and sourcing these reducing flow splitters or double L's, and I'm currently working on getting these in stock at our own at Solstice Eco Building Supply. And so if anybody's having trouble sourcing them, contact me and I'll see if I can get you in touch with them. And so the next parts in the system are the outlets, the mulch basins, and the mulch shields. And by outlets, we're just talking about the end of the pipe, where the gray water comes out of the piping and is now becoming irrigation water around the plants. And there's several ways that you can do these outlets. Outside of California, in some states, you can have the outlet just deliver the water above the mulch basin, such as the image A in the upper left. This will allow you nice, simple, easy access. You can always make sure that your outlet pipe is not having any obstructions. It's easy to maintain, but in California, we're not allowed to do this. We have to have all of our outlets be subsurface. So only the images there, C and D, as well as the one in the lower left, B, are subsurface. And so some building inspectors won't go for image B in the lower left with stacked rocks. And so what's most typically wanting to be seen by the building inspectors is to have either an irrigation box like C, or a 5-gallon bucket or 3-gallon bucket, some sort of a bucket to create that airspace around the outlet, or using the more expensive and far more labor-intensive approach of the subsoil infiltration galleries, or infiltrators as they're called. And these big plastic domes come in sections, usually 3 or 4 feet long. And one of the things I don't like about them, besides the cost and labor to put them in, is that they are, by nature, you're having to deliver the water much deeper underground. And one of the goals of this gray water irrigation is to deliver that gray water as high as possible within the landscape so that the most roots of the plant can benefit from it. So with these outlets, it's important, especially here we're talking about subsurface now in California, there's various different ways that you can have that subsurface mulch shield. And so this mulch shield, its purpose is to create an airspace around the end of the gray water outlet, so that no roots that could be growing through the mulch basin itself, that they won't actually have a chance to get in and clog the pipe. And so if you don't have an airspace, the roots will simply just follow the soil, follow the mulch, and climb right up into the pipe. And so this airspace is what some people call an air pruning method, trying to deter roots from reaching through the air to get into the pipe outlet. And there's lots of different ways you can do it. My personal favorite is in the upper right. It's off the shelf, 3.5-gallon bucket. It's a nice big size, makes for easy, roomy access for getting in there and servicing the mulch basins annually. And you can also buy in the lower right there, you can see the off-the-shelf irrigation boxes. These are nice because they have nice fitting lids, and everything is ready to go. You don't need to modify them. And so for quick installation, sometimes it's easier and more cost-effective just to get them ready to go like that. And then the stack rocks is another method. Where we're out here in Joshua Tree, we have so much rock around, and this is a nice natural approach for doing a mulch shield. I will say that you do have to stack these rocks with care, because if they're just haphazardly thrown together, there's a chance that this mulch shield could collapse, and then it just completely defeats the purpose, because now the roots could easily climb up into the pipe. So if you're going to go with this route of stacked rock mulch shield, just make sure that those rocks are stacked with care and are nice and stable. And then the lower left, the 5-gallon buckets, I try to avoid using the 5-gallon buckets when possible, just because it makes the mulch basin have to be deeper. And so if you're able to do it with a shorter mulch shield, I prefer that. And but in some cases, because the distribution piping has gone a long way away from the house to get to the plants that you want to irrigate, your mulch basins sometimes have to be pretty deep. And so in that case, a 5-gallon bucket will allow you to be able to come up closer to the surface. So the next element in the Greywater system, and a really important one, is the mulch itself. And the mulch first job, first and foremost, is to filter out the Greywater. And we're talking about filtering out oils and any particulates that would otherwise get through and could potentially start to clog the soil and slow down the infiltration into the soil. And so wood chip mulch is a really great mulch that you can see there in the image on the right. Some of the other aspects of mulch that are contributing to the system is that it also, especially in our arid climates, it'll also reduce the evaporative water losses. And so we'll go above and beyond with the mulching out here in the high desert and mulch as much as we possibly can. And it will protect the roots from the extremes, especially the extreme hot, because the roots don't like to get so hot. And then it's also supporting the healthy soil food web by having more organic material to start to break down and create compost within the soil. And the more organics we can get in there, it starts to aerate the soil and make nutrients more available for plants to uptake all around, making for a healthier system. So the wood chip mulch is really the best mulch to use because of its ability to absorb oils and doesn't break down so fast. But there are other things that you can use. You could use straw, you could use branches, leaves, any other debris. Where we're out here, wood chip mulch is at a premium and difficult to come by. And so what I've done in several cases is use straw or branches, things like that, for the bulk filling of the mulch basin, and then topping it with a few inches of wood chip mulch on top, since it's harder to come by and coming at a premium. But by doing that, though, we just have to service the basin, or I should say add mulch to the basin more frequently, because that straw and leaves and things like that will break down much faster than the wood chip mulch will. And so that mulch is sitting within a mulch basin, and this is a really important part of the Greywater system. That the mulch basin does several things for you. One is it gives you a surge capacity to be able to absorb large amounts of Greywater at once. So if a bathtub is draining, for example, that big amount of big volume of water that's coming down the pipe will now have a place to absorb within the mulch basin and not overflow. We don't want the Greywater to be above surface and overflow the basin. Also, when these basins are dug in a way where they're flat and level, it allows the Greywater to flow out evenly around the plant and distribute that water. If you have a completely circular mulch basin, you'll get that water to flow all the way around when it's nice and flat. So here's an example of a mulch basin from a project out in the high desert here. And you can see the 3.5-gallon mulch shield that's there. And once it was fully filled in, all you see is a little rock there in the image on the upper right. And that's because what we have is a little concrete 12-inch by 12-inch paver that goes on top as the lid. And then I prefer to mulch over the top, not only around the mulch shield. If you see the diagram in the bottom, This diagram is just showing the mulch within the mulch basin itself. But what we like to do out here is actually spread that mulch all the way to the plant, other than holding it back just around the trunk of the tree, and that's why there's some rocks that are placed there to protect the trunk from having the mulch up against it to prevent any rotting issues. So the mulch basin looks like it's much larger than it actually is because of that, because we're actually spreading that mulch right on top of the soil. And also, difference between the diagram in the bottom and the image in the upper left there, if you're using like an irrigation valve box, you can set that on a few bricks where you're having good free flow access for that gray water to flow out into the mulch basin. But another method is to then use a bucket that could be setting on the ground, for example, and having holes drilled into that. And then it's important when you're filling that basin with mulch that you're also having a bit of mulch inside the mulch basin, inside the mulch shield itself, so that the gray water is falling onto the wood chip mulch, so that you have several inches of that biofilter filtering out the oils and the particulates and things. So this is kind of a good place to stop if there's any questions, Laura, about the various elements in the branch drain system.
There are some questions, and my computer bumped me off, so I'm not able to see the chat box right now. I'll get back on in a sec. So if anybody recently asked a question, sorry, I might not have seen it. There was a question about how steep is too steep, referring to when you said 1/4 inch per foot slope.
How steep is too steep? It's pretty much not a concern to go steeper than 1/4 inch per foot in terms of particulate matter and things like that. With plumbing of, let's say, a toilet line, for example, the reason that water is at 1/4 inch per foot is you don't want the water to outrun the solids, and that at 1/4 inch per foot, the water is what pushes the solids along. So it's ideal to try and have 1/4 inch per foot. So if there are any solids that get into the Greywater system, that you're able to push that along with the water, but it's not critical. So if your backyard, your yard that you're irrigating has a steep slope, for example, it's okay if you need to go down that slope. In some cases, on a really steep slope, we'll put in a 45-degree fitting and then go down at a 45-degree angle down the slope for a while, and then level back out with another 45-degree fitting at the bottom. So that's one way. Or if you're terracing, you could go down with a 90-degree drop and drop down to the next level, and then going into a long sweep 90 at the bottom of that drop to bring it back out to level or 1/4 inch per foot to be accurate. So it's not absolutely critical is my answer. What do you think, Laura?
Yeah, I totally agree. And just if in flat yards, if you do go too steep, like steeper than 1/4 inch per foot, your pipes end up getting deeper and deeper and deeper, and that just creates a lot more work and a less efficient system in terms of irrigation. So that would be the risk of going too steep if your yard is flat. If it's downward sloping, then it doesn't matter.
Right, yeah, for sure. The flat yards, for obvious reasons of not wanting to dig more than you need to, and then also for the goal being to deliver that gray water as shallow as possible. So we want to not go steeper than 1/4 inch per foot in a flat yard if we can avoid it.
And then there was another question about what if the system, if there's 3 bathrooms that are stacked one above each other, any potential issues with installing a system from that home?
So what I'm gathering is then that gray water, you're diverting whatever gray water from the stacked bathrooms upstairs and then going down into a standpipe that's most likely going outside the building, unless this is a retrofit and you're able to open all the walls of the building. In that case, if you have multiple bathrooms, you might end up with multiple systems. So if you're starting off with all of those sources already separate, you're going to have so much gray water from multiple bathrooms that it's a good opportunity to keep them separate to begin with. And you can bring one bathroom out to one zone and another bathroom out to another zone. So if you're having your sink and your shower water, for example, from one bathroom, that just goes to one area and keep the other one separate. If you're combining them, I don't can't say offhand the volume, how many fixtures you can get in a 2-inch pipe. But if you're having to go to a 3-inch pipe by combining those, then you need to source a 3-inch flow splitter to reduce down to 2 inches, and then reducing again from there. So it gets more complicated. If you can keep everything from having to go into 3-inch pipe, it's a better thing from the get-go.
Yeah. And I'm logged back in, and if anybody did type in a question in the last 5 minutes or so, or if it hasn't been answered yet, please retype it because the dialog box got deleted. So maybe we'll just go on, and then some more questions will probably come in.
Okay, sounds good. So going through the design and installation process, the first thing that you need to do is to calculate how much gray water is going to be produced each week from the various gray water sources. And Laura talked about that a bit in the Greywater 101 presentation. Various ways to do that. Oftentimes shower heads, for example, will have the flow rate written on the shower head, or you can, to get a more accurate rating, just get a bucket and turn on the shower for 1 minute and measure how many gallons of water you get in that 1 minute. And washing machines, oftentimes the usage is published in the manuals, and we know that with the efficient machines, you're looking somewhere between 12 to 25 gallons per load, and the older top loaders, 25 to 50 gallons or 35 to 50 gallons even. So just calculating how much water is going to be produced each week. So how many loads of laundry might be done that week. And then once you have that figure of how much gray water you're going to have, then to sketch out and determine which plants are going to get irrigated, whether they're existing plants or whether you're adding new plants, and trying to match the plant's water needs with the amount of water via the various amount of flow splitters that you might add. So you might go through several design variations. Anytime that I'm doing a new design like this, oftentimes I'll actually sketch right on the soil. In our area, we've got such sandy soil, and so it makes it really easy to take a stick and draw the system layout in the ground. And it is helpful to just try and figure out what's going to be the most efficient system layout before you start going and buying all these materials. There's many ways that you can do it, but just trying to do it to make the best use of the resources. And then the next thing you need to do, once you know how much gray water is going to end up at each plant, to calculate what size you need to dig each mulch basin. And so basically what you're doing is taking, in this case, gallons per day, not gallons per week, but what's the maximum amount of gray water that mulch basin would see in 1 day, and multiplying that times the soil coefficient. And you can see in the table there, it makes a big difference what type of soil that you have in the bottom of the mulch basin. If it's sandy soil, you only need 1/4 of the amount of surface area as you would if it were clay soil. And so knowing your soil type is an important part of the process. There's less technical ways of doing it by simply getting a bit of soil in your hand, slightly moistened, and feeling the consistency of it. And if it's holding together really well, and you can create a little worm, for example, or a snake, you probably have a bit of clay in there. If it's really crumbly and won't hold any form, it's likely mostly sand. And if it's extremely sticky and you can bend it all the way around into a full ring, you have a very high amount of clay. So those are kind of easy ways of testing, or you can put the soil in a jar of water, about half full of soil and the rest with water, and shake it, and you can see what settles out, and you have the sand and the gravel settle out at the bottom, and then the next would be any of the silts, and then finally the clays are the last to settle on top, and you can see about the percentage of gravel and sand, silt, and clays. And then for really technical jobs, if this is a permitted job where you may actually be required to get a soil test and figure out what type of soil. So once you know the sizes of the mulch basins, and by the sizes, when we're talking about the square footage, we're talking about the bottom flat surface area of the mulch basin, not the volume of it, but just the flat area where the water is infiltrating into the soil. So the very bottom. So if a 2 foot by 2 foot mulch basin will give you 4 square feet. So now that you have the system designed and sketched out, and you know how big your mulch basins are going to need to be, the next thing is I find it helpful to mark out all the areas that are going to be trenched and all of the mulch basins themselves. And in some cases, it can be helpful to actually lay the pipe and fittings on top of the ground and just dry fit the pieces together to try to help solve the particular installation details. And then marking it with either ball field marking chalk, which we get a bag of this ball field chalk for maybe $5 for a huge bag that'll last forever. Or we could also just use regular old baking flour if you don't have access to chalk. And then once that system's all marked out and you're ready to go to do the hard work. And so start by digging out all the mulch basins first. And then once the mulch basins are all dug out, to then dig your trenching for all the distribution piping. And I found that it's much easier to get your trenches properly sloped at 1/4 inch per foot first before trying to lay the piping in there. And it makes for a much cleaner and more efficient installation to do it that way, instead of putting the pipe in and going back and forth to just try to get the grade sloped first. And there's many different ways you can measure that slope. One is you can get a grade level, which has marking lines on it to tell you when you're at 1/4 inch per foot. Or you can simply use a 4-foot level with a 1-inch block that's taped on one end. So when you lay it down on the grade or on top of the pipe, and it reads level, then you know that you have a 1/4 inch per foot slope. And the same could be done with a simple 2-foot level with a 1/2 inch block taped to the end for shorter sections. And then one of the things I like to do is to use a string line for long straight runs. So if you have, say, a 30-foot section of pipe, of trench that's all nice and straight, or longer. I've had situations of 60, 90, 100 feet of straight pipe to go irrigate in an area far away from the source. And if you don't have access to a more expensive builder's level, then a simple way to do that is to just pound a stake at each end of the long run, and to tie a string to those stakes so that string is level, and you can check the level with a little bubble level that hangs on the string, and there's just a few dollars at any local hardware store. And once you've got that string line level, then you can measure from it, and I'll have another image that shows that a little clearer next. The last way that I use to check for slope is using what's called a builder's level, and it's similar to a transit, like what surveyors use, but a little less complex. All it is not a telescope, I guess it is a telescope of a sort, that's mounted on a rotating axis. So you can it'll swivel around, and you'll get a 360-degree sight line that once it's set up and calibrated to be level, it'll just give you a level sight line. And this is an expensive piece of equipment. I want to say my builder's level costs maybe $300, $250 to $350, somewhere in that range. And it also requires a second person. So one person is looking through the scope, and the second person is holding a measuring stick. And when you measure different points, you get relative height changes. And for doing big jobs and a lot of measurements, I've found this to be the fastest and most efficient way to do it when you have a 2-person crew. So when you don't have a builder's level and you've got a long straight run, this is that string line that I mentioned. So once that string line is set totally level, you can go down the pipe or the trench and just measure every 4 feet. And every 4 feet, it should be 1 inch lower. And also in this image, there's my favorite cutting method for cutting the ABS pipe, and that's just a simple miter saw. Just makes for nice, fast, clean square cuts. So then the next part is to cut and assemble all the elements and to dry fit everything in your trenches that you've dug. And it's important that we dry fit everything first, because sometimes as we get started, you think you're okay with your slope, and then things need adjusting, or some pieces need to get cut shorter. And so we dry fit everything to make sure everything is great before we glue it. And then once you've gotten everything dry fit and assembled and you've checked the proper slope everywhere and everything looks good, at that point you can glue the system together and start from the top of the system and work your way downward. The only part of the system that I don't like to glue is the inlet to the flow splitter itself. And the reason for that is if the flow isn't quite right, if we had glued that fitting, it's pretty much locked into there and it's difficult to manipulate it after the fact once it's been glued. But if you don't glue that one piece, then you can come back later and you can adjust the angle on the flow splitter if you need to send more or less water one direction or the other. So just remember not to glue that one inlet pipe on the flow splitter, and everything else would get glued. But at the same time, making sure that that flow splitter component is well seated, that the pipe is well seated within the flow splitter hub, so that you're going to get a good seal in there. And I've never had a problem with water dripping out of it at that source. I've opened up the valve boxes and not seen any dampness down there. So as long as it's well seated, we're just talking about real low pressure gravity flow over it. It's not an issue. So basics, if this is new to anybody, just to cover the basics of gluing the ABS pipe, you want to put a good amount of glue both on the exterior of the pipe as well as on the interior of the fitting, and push them together and give a little quarter turn or eighth turn. And it's important to hold the pieces together while the glue is setting, especially when it gets hot. I found the hotter it gets, the more likely that the pipe and the fitting want to push themselves apart. So it might take 5 seconds, it might take 15 seconds. Just hold them together as long as it takes until they're firmly set. And if you have any pieces that are really critical, that the angle between the pieces are critical, especially if you have multiple fittings going together, like a street fitting that's going into another fitting, and that angle is critical. You can put a little mark on each side called a marriage mark, and that way when you're gluing the pieces together, you just line up those marks and you know you're right back where you wanted to start. So just a few images of some pipes and some systems, distribution piping getting glued together and put together. And you can note in the upper right there, that 2-inch flow splitter sitting on a brick there that's been leveled, and then a series of fittings that's reducing it down to the 1.5 inches. The issue with this method in the upper right of reducing down to 1.5 inches is it takes a bit of fall out of your pipe. So if you're starting with a flat yard and you really don't want your pipes to be so deep, then you're already losing. The trench is getting deeper, I should say. And so this is where having that reducing flow splitter that goes from 2 inch to 1.5 inches would be so nice to not have to go deeper than you'd like. So now at this point, all of the piping and fittings should all be glued together with the exception of the inlet of the flow splitter. And everything's been checked for proper slope, and the flow splitters are on the stable blocks. And so at this point, the next thing you can do is to check for proper flow. And so just go back one image here. In the upper left part of this image, there's a clean out there on the sanitary tee at the top of that pipe. So one way is you just open that up and put a garden hose in there and turn it on, or you can simply go into the house and turn on the fixture that's going to be the Greywater source. And once you get the flow to be consistent and stable, then you can go around to all the various outlets and inspect them and see if one outlet's not getting as much water as you'd want it to, or maybe another outlet's getting too much water. And if you're going for even flow, an even volume of water coming out each one thing you can do is, if you have enough people on site, is to get the same size container. So in this case, in the image, a quart mason jar, we've used yogurt containers, anything that's the same size container. And then on the count of 3, everyone just puts that container underneath the outlet pipe. And you can quickly see if any of the outlets have too much flow or not enough flow, and if it needs to be adjusted. And for adjusting then at this point, you go back to the flow splitters, and you can put a shim underneath the flow splitter if one side needs to get lifted up a little higher than the other. and just start to play around with that until you get the flow how you'd like it. And then Laura sent me these images from the last Greywater installer course they did. She said some plumbers had installed this system of trying to have adjustability and keeping the flow splitters where they wanted them, where they pounded rebar stakes on either side of the pipes and tied wire around that. And then because of the roughness, the rough texture of the rebar, it held the wire from sliding up and down. And then they could adjust the pipe up or down however they wanted and got it stable before backfilling. So there's a new method for adjusting the flow splitters. So just another image of a system now. Everything's been glued together other than the inlet to the flow splitters, and flow testing has happened. You can also see in this image the water is flowing nicely all the way around the mulch basins. And also mention that this particular project, the mulch basins are oversized for what they need to be, and that's for a combination system I'll talk about a little bit later, where we're using these basins for rainwater catchment as well. So your basins don't necessarily need to be as large as what you're seeing in these images. So at this point, yeah, everything is assembled and the flow is good. And so the next thing you can do is to install the mulch shields at the ends of the outlets, as well as the valve covers around each of the flow splitters. With all those different ways, you could use the bucket method or valve boxes. And if you're making your own mulch shields and valve boxes out of buckets, you just drill a hole in the bottom of the bucket, and you can use a jigsaw and use a paint can or a lid from a cooking pot, as a marking for a circle. And we purposely don't cut out the entire bottom of the bucket and leave a few inches of that, and that's to give rigidity to the bucket. If you were to cut the entire bottom out, you lose the integrity of it and it gets wobbly. And then using a drill to cut holes in the mulch shields. I initially started with some smaller holes in the bottom of these, like this yellow 5-gallon bucket, for example, and through just observation of various systems that we've done, I found that there's no need for small holes. My concern was that maybe the mulch would start to flow in too much into the bottom of the bucket, and so we then went to larger holes, and it works just fine. So there, found about a 1-inch size hole is just perfect. And then a couple images of the valve boxes using buckets around the flow splitters. And also simultaneously at this time, you could start to begin to backfill if there's any areas where you're walking back and forth a lot. So the order here, it's not critical that you're installing the mulch shields and such first. If you want to start backfilling any of the areas first, you could do that. And so fun part of cleaning up the site by being able to backfill all those trenches. And one note of caution, just to make sure that the pipes are well seated and well supported before you're fully backfilling. Sometimes your trenches might have little dips and valleys and things like that. And if you just pile the dirt on top, you could end up with a little bow in that pipe from the pressure of the soil above. So just to make sure that you start by sprinkling the soil in there and supporting the pipes well before you fully backfill it. And then backfilling around all the valve boxes and such as well. And then getting close to the end here, fill in the basins with mulch. And this is that same project where I had mentioned that the basins were larger than they needed to be. So these mulch basins look rather large, and we've also had the mulch go all the way up to the trees. And you can see here in this image on the left, we use straw for the bulk of the mulch because that's what we had available to us, and actually had a whole bunch of straw bales that had sat out and were no longer useful for building, not good for bedding for animals, and so it was actually a perfect use of these composting straw bales to use them as the starting bit of mulch. And then we had about 3 inches of the wood chip mulch that we put over the top. You can also see in this image salvage materials that are used for lids over the mulch shields. So if it's a permitted project and your inspector is able to go for that, you can do that sort of thing. But there's other options. Oh, and I'll just mention also, when you're putting in all the mulch in the mulch basins, if you have enough mulch available to you, it's a good idea to start by mounding or overfilling the mulch basin slightly, because you will get settling that'll happen with time, and as the system starts to get used, it'll start to break down the mulch that's in contact with the bottom of the soil, and so you'll get some composting happening in the bottom. So the whole mulch basin will start to settle, and so if you start with it overfilled, you won't have to add mulch as quickly. And just to finish mulch there, and also most people wouldn't really think of it as mulch, but because we have so much rock around where we're at in Joshua Tree, rock is actually an incredible mulch. In the desert, if in such an arid climate, if you turn a rock over, it's surprising how much more moisture you might find underneath the rock where everything else around it is dry. So in this case, these are boomerang swales that were dug in on a sloping hillside, and on the bottom of the boomerang swales, we placed rock to help stabilize and add additional mulch, as well as some mulch, rock mulch that was placed on top of some of the mulch closer to the tree. Oops. And more typical installation in terms of size of the mulch basins. In this case, another example where we're using a straw for the bulk filling, and then the wood chip mulch on top. If you have access to good wood chip mulch, I would just go with the straight wood chip mulch. The straw is going to definitely subside much faster and compost much faster. So it's just preferable. This is just what we've had to do to adapt to our lack of availability and high cost of the wood chip mulch. So the system's now cleaned up and finished, raked up, and the last final steps are just any additional cleanup, things like sealing any of the gaps and cracks where the pipe penetrations have gone through the building, important detail, and to paint any of the exposed piping with either a matching or complementary house paint will help keep the sun off that pipe. And then any other additional cleanup that you might have, raking up and just making everything look nice and clean. And you're done, maybe. Okay. Any questions at this point regarding the system design and installation? There's a question about how much water does it get me, and I'm just going to refer back to the go over how to calculate the other requirements. We'll have another webinar next year. Laura, sorry if I'm interrupting, Laura. I was thinking it might be a shorter question. I couldn't hear it, any part of that question at all. It was all choppy and broken up. Oh, well, can you hear me now? No, it's all choppy. I can't hear anything. I mean, I hear sounds. I just don't hear anything coherent. I'm still here. Keep going. Finish it up. Okay. All right. Well, because I'm not able to hear any of the questions that Laura's asking, hopefully she'll be able to get the sound issue fixed on her end, and I'll continue. There's a few more slides here in the presentation, and hopefully we can get to all those questions at the end. So once the system is now complete and the maintenance is something that you just have to keep in mind. It's pretty easy, actually. There's not really a whole lot to do with the branch drain system. Basically, annually, we at a minimum just go out once a year to inspect, and oftentimes there's not much that needs to happen at all. If you have a lot of organics, let's say, for example, with kitchen sink gray water, there's more organic material that's going down the pipes, things like that. In that case, the mulch is going to break down much quicker, and you'll have soil essentially and compost at the bottom of the mulch shield. And so you'll need to clean that out and replace that with fresh mulch, so you have good absorptive abilities again. But with the majority of branch drain systems, the maintenance is really simple, and it basically just starts with opening up the mulch shield and removing the lid and inspecting, and if there is any of that composted mulch that's now rich black organic soil or compost, just remove that, and you can spread that around elsewhere in your garden as a compost nutrient, and then to replace that with fresh mulch inside the mulch shield, and just making sure that you leave several inches of fall between the outlet and the mulch so that the roots can't climb into that outlet pipe. And then leave the lid off on the mulch shields at this point while you go through the next steps. And so the next thing you do is to inspect the splitters. So go on into the house, or you can put a hose in through the clean out at the beginning of the system, and to get a good flow of water going through the system. And once you have a steady flow, you can go back to all of the mulch shields and the outlets and inspect the flow. And if something's not getting as much water as it should, go back to the flow splitters and open up the lids there, and you can remove the clean out plug and inspect the flow splitters. And sometimes you might have just a bit of debris that got caught on the on the little spine in the flow splitter. I've heard of other people saying in moisture climates that slugs have been the cause of an issue. And so what you can do is you can open up the inspection port, clean out any debris that's visible there, and put a garden hose in through that clean out and blast the system out with water and flush out anything that might be causing restriction in the flow. And then the last thing is just to maintain the mulch basins. So you might have to do this more often than annually. It just depends on how quickly that mulch is breaking down. But to add mulch as you need it to keep that mulch basin full. And if you are using kitchen sink gray water, you just have to keep in mind that the maintenance schedule is going to be much more frequent because of the additional oils and particles and things that could clog the soil. And so you may actually have to open that up twice a year or even 3 times a year to make sure that everything's flowing well through there. And then the last thing, I'm just going to talk about some additional options. These are some things to keep in mind that, for one, not all gravity systems need to branch. If you just have a seldomly used sink, for example, or a plant that has a really high water need, like in this diagram, the banana palm is shown there, that maybe the amount of water that sink is producing is just enough for that plant, or because it's so infrequently used, you might actually not need to branch at all. So it could just be a very simple system. And then one thing that I've done that I really like to do, before filling the mulch basins completely full with mulch, the first things that I put in the bottom of the mulch basins are decomposed wood and brush and things like that are lying around on site. I'll just scan around and take a look around the property. And if I'm being hired to do this job, ask the homeowners if they would mind if I'd put any wood scraps that are lying on the ground, or a chunk of decaying firewood, or things like that. And then the more decayed, the better. It's just full of all these beneficial microorganisms. And the reason that I do this is it's essentially inoculating the soil at the bottom of the mulch basin with all these beneficial microorganisms, the mycorrhiza and all these wonderful things, fungi, things that are great for building a healthy soil food web underground. And this will improve the absorptive qualities of the soil and help aerate the soil underneath, and help the plants to be able to uptake water and nutrients much better than if it was just the bare soil below it. And a couple of images of some mulch basins where we're filling with just various old fence boards and brush and things that were on the property. And this is a good segue here to the next topic, and the last topic as well, is this image on the lower left. It's a really big infiltration basin, and the reason is this is a dual function basin. Not only is it an infiltration basin for the Greywater, there's 4 outlets there that you can see all in a row, but it's also an infiltration basin for rainwater. And so this this particular property, directly behind where I was taking the photograph, there's roof of a garage that's dumping water onto the ground, and that water's ponding in an area of the property, and in other areas are getting runoff. And so we decided to stack functions and combine the graywater and rainwater infiltration basins into one by providing this basin where the water can accumulate and pond within a mulch basin and very quickly then absorb into the ground. And it does, really does a lot of functions for us. You can also see in the background there, it's actually two separate basins, and this is hydrozoning, if you will. The first area is much more of an oasis zone where the inlet is on this side. The rainwater catchment inlet is on this side, and then 3 graywater outlets. And so the plants that this client had wanted to use were all California native plants that are commonly found in riparian corridors and even in California desert riparian corridors. And then the last stage was planted with a native plant in this area, honey mesquite, which has lower water needs. So if that rainwater infiltration basin was ever to completely fill up, it then overflows into the secondary basin for the mesquite tree that's there, and it only has the 1 graywater outlet as opposed to the 3 in there. And there's let's see here, the next image. Just the phase 1 plantings had gone in for this. So there's only a few plantings that are there, but the 4 outlets that are there are also going to be irrigating some Mojave grape, a local varietal of a native grape that grows in the riparian corridors around Southern California deserts, and having that trained up to go up a trellis. So there's going to be other plants as well as some other flowering pollinator attractors, bird and insect bee attractors, butterfly attractors, things like that, because we have quite a lot of graywater that's accessible. That's coming out from a shower and sink upstairs, both of those, as well as a laundry, and then with all the rainwater catchment. Oh, and also a swamp cooler purge line as well. So quite a bit of rainwater and graywater going into this. So with the idea of the stacking functions, one of the other benefits of doing this is that all this wonderful rainwater that flows into it is also flushing all the accumulated salts from soaps. So many soaps have sodium chloride and other types of salts that are in there that over time are harmful to the soil and the plant and its ability to uptake water nutrients. So this rainwater helps flush that system, and it also, by giving all those plants the occasional really deep drink with the water they love most, it's encouraging them to reach deeper for that water as opposed to just having a little bit of gray water at shallow root zones. So that stacking of functions is really nice. And then another image from this system you've seen a few images of. This system was designed so that the roof of this small cabin, the water then flows down the vertical standpipe and goes into the distribution piping. And so the rainwater flows into the basins via the mulch shields and outlets. And so even a small bit of rain will give that system a good flush of rainwater. And lastly, just the resources here. And first resource, I definitely want to mention Laura's book, The Water-Wise Home. This was just published, I believe, this year. And it's really a great resource. Lots of good diagrams, a lot of great up-to-date information with regards to codes and just all-around good resource for graywater, as well as water-wise practices in general, not just graywater, rainwater catchment, composting toilets, great resource. And then the original, go-to handbook here, Create an Oasis with Graywater, Art Ludwig's, still a very good resource. Just had a recent new printing, and so it's another one to keep as part of a resource library. And then the San Francisco Graywater Design Guidelines for Outdoor Irrigation, and Graywater Actions Question and Answer Forum. And I'm looking at the time. I apologize. I've gone a little long here. We're 10 after 5. So thanks, everyone, for hanging in there. And Laura, any luck with the sound for any questions that people have asked?
Can you hear me?
Perfectly.
Okay, great. So we're all good on the questions. And anything else anybody wants to type in? Okay, I think we're all good. So thank you so much, Nicholas, and thanks everybody for joining us. We have our last webinar coming up in 2 weeks of the season, and then we'll have another one starting in 2016 with more topics like plants and irrigation and other types of systems that we haven't covered yet in detail. Thanks, everybody.
All right.
Have a good evening.
Thanks, Laura.
Bye.